Okay, in this video, we're going to solve this problem right here, and we're going to use inverse matrix. Now, when I solve this problem, I'm going to assume you already know how to use the inverse matrix approach. I'm still going to show every step, but if this is completely new to you, I recommend watching the video in the description box. So we're going to use matrix. So let me say matrix A is equal to, I'm just going to take the coefficients, 2, -3, so 2, -3, and 4, -1. 4, -1. Now matrix X is just going to be our letters, X and Y, our variables, so X and Y. And matrix B is going to be our answer, so -9 and 7. Then we're going to say matrix A times matrix X is equal to matrix B. And we can prove it real quick. 2 times X, -3 times Y. 2 times X, -3 times Y is equal to -9. So it's important that you know how matrix work. Likewise, 4 times X and -1 times Y, it matches here, is equal to 7. So we want to solve for X and Y. So we essentially want to isolate X. Now you may say, why not divide by A? Divide by A. With matrix, you can't divide by them, so instead we have to use the inverse. So I'm going to say the inverse matrix A times pretty much the same stuff. Matrix A times X is equal to, if I put the inverse matrix on the left, I have to also put it on the right. So the inverse matrix A times B, matrix B. And essentially these two cancel out. You get an identity matrix, but we can just say it cancels out. And so we get X is equal to the inverse matrix A times matrix B. So now we need to know what is the inverse matrix. So this is more of a formula. The inverse matrix A is equal to 1 divided by our determinant, so absolute value of A, times the adjugate, I'm going to label as ADJ, of matrix A. Now the determinant is going to be pretty easy to get. You essentially multiply the diagonal, so 2 times -1, and so we get -2 minus, we do this diagonal, -3 times 4, so you get -12, and so a negative is a positive, so you'll get a plus 12, which is going to equal to positive 10. So now we know this piece, 1 divided by this determinant. We don't know this piece, this adjugate A, and then we'll multiply by matrix B. So let's actually put it together right here. So we're going to say we have X is equal to the inverse matrix, 1 divided by our determinant, so 1 divided by 10, times the adjugate A. So that's not also that bad. To do this, you switch this diagonal. So this is 2, -1. Now it's going to be -1, 2. So -1, 2. And then this diagonal, you flip the sign. So this 4 becomes a -4. And this -3 becomes a positive 3. And then we're going to multiply by matrix B. And matrix B is -9, 7. -9, 7. And so now let's multiply it out. So we'll keep our 1 divided by 10, but let's multiply by the 2 matrix. So -1 times -9 will give us positive 9. Then we take 3 times 7. 3 times 7 is 21, so plus 21. Likewise, -4 times -9 is 36, and 2 times 7 is 14, so plus 14. And so we'll continue it. 1 divided by 10. The matrix 9 plus 21. 9 plus 21 will give us 30. 36 plus 14 will give us 50. And 30 divided by 10 would give us 3. 50 divided by 10 would give us 5. And we said matrix X is equal to 3, 5. The 3 corresponds to the X value, and the 5 corresponds to the Y value. So let's write this down. X is equal to 3, and Y is equal to 5. And we can always check like normal. 2 times 3 is 6. -3 times 5 is -15. 6 minus 15 is -9. That's correct. Likewise, 4 times 3 is 12. 12 minus 5 is 7. That's correct. Obviously, with this problem, if you use the elimination method or substitution method, it would be much faster. But the nice thing about this particular method, if you can use a calculator and it has the matrix function, you can solve very advanced systems of equations using your calculator. And that's pretty much it for this video.